This is the official class for 121. So samsclass.info is where a lot of the materials are. And when you click CNET 121, you get to my 121 computer forensics class here. We've been through the first class already, and there are videos here of everything that happened the first day that anybody can view. And now we're going to talk about Windows operating and file systems and the first couple of projects. So to do that, let me get in Canvas, which I thought I had open here. I guess I must have. What's this? Yeah, all right, must have closed it. I'll just get in again. All right, because I haven't made slides for this course. Instead, I'm using a sort of summary of the textbook in a written form that I inherited from the teacher that set up this page, and it's good enough, so I've been using it. So here's lecture 2 about Windows operating and file systems. All right, so all right, you have to understand how operating systems store data. As we talked about last time, the point of computer forensics is finding evidence on a machine that shows you what has been happening on that machine. And this is useful for a lot of purposes. It's useful for crime, getting evidence that a criminal has done something bad on the machine. It's useful for incident response, finding out that some kind of hacker has been wandering through your machines at your company doing something they shouldn't, and other related fields. So you have to understand how data is stored on the machine and how to retrieve that data. So the fundamental storage of machines and all modern operating systems goes through a file system. This is not the only way to do it. There are other machines. I've used spectrometers that just have a bar of iron, and they slide the bar of iron back and forth, and the magnetism on the iron just gets built up in a pattern, and there isn't any named files or anything. But in computers, you have a file system with names of files and names of folders and a directory with all those objects, and the data stored in clusters. And so you'll understand how that works. So allocated storage space is also called active data. This is data that is currently in use, so it has a file name, it has a creation date, and it has an owner. These are the normal files that you can see by opening the desktop and your documents folder. Once you delete those files, they become unallocated space. The actual contents of the files remain on the disk if it's a magnetic disk, and sometimes they do and sometimes they don't when it's a solid-state device. But the file name and the owner and the timestamp are lost. So that's unallocated space, and as we've talked about, forensic tools can recover some data from unallocated space. Some deleted files can be recovered in all or part. But the main thing people think about is the active data, the data that you're still in use, that hasn't been deleted yet. So a byte is 8 bits. Everything is stored as a series of bytes, and everything on a hard drive or an SSD is stored as sectors. You cannot store just 1 byte of data. The smallest amount you can store is 1 sector, which is typically 4,096 bytes. So even if you want to store a small file, it will use 4,096 bytes on the disk because it would be too expensive to index smaller units. So they break it up into units of 4 kilobytes, and you index those. And so a sector is a sector that has some kind of defect, so when data is stored and you read it, it comes back with an error. When sectors are determined to be bad, the disk's controller unit will automatically move the data to another sector and use that instead without telling the operating system, and this has some important forensic consequences. What it means is, if you save a file on a disk and you look at the master file table and it tells you that file is stored in cluster 10,005, 10,006, and 10,007, that is not really true at the hardware level. Some of those clusters might have been silently replaced by extra clusters. If you buy a 100 gigabyte hard disk, they really give you some extra, like 103 gigabytes, because there's extra clusters that are used for this silent substitution of failed clusters. And if you try to erase a file, you can erase clusters, but you're going to erase the remapped clusters. So if you have a bad sector, you've stored data on it, and some of the bits might be unreliable, but most of the data is still there, and there is no way for you to erase it. This is why companies do not donate old hard drives to schools or anything. They always just grind them up physically, because there is no way to really get all the data off an old hard drive anymore, or an SSD. In principle, you can get most of it by issuing an erase command, but you really do not know that some portions of it are not in unreachable bad sectors. Now, the other thing you could do is the people that manufacture the hard drive and SSD have firmware built into it, and they usually have a firmware erase command, which is supposed to really erase everything at the hardware level, but you have no way to verify that. And my friends in the industry tell me that frequently in practice it fails. So that's an issue. So if you want to ever reuse a device, you have to do what iPhones do. Ever since the iPhone 3S, Apple has totally solved this problem. Every iPhone SSD is encrypted before you ever use it. The operating system always has hard drive encryption turned on. Everything you save is being encrypted continuously, and if you go to the settings and hit reset to factory defaults, it erases the key. So all the data you've ever stored is now unreadable. It's an instantaneous process. It doesn't involve trying to wipe out anything. They just erase the key, and it's extremely effective. And several years ago, a forensic company wanted to test this, and they bought 100 used iPhones on eBay, and they tried, and they could not recover any usable data off any of them. So if you do it that way, that is the safe way to use hardware, where there is no data on there that's not under your control. But Windows machines and Macs do not typically do that. All right, so that's an issue. All right, so your clusters can be a different size. You can group sectors into clusters, but typically it's the size of 4,096 bytes. So a track is this track all the way around the disk. A sector is one little pie-like slice of this, and a cluster is a group of those. A sector is almost always 512 bytes. That's the actual hardware, smallest unit of data you can store. But when your file system, you typically cluster them together into 8 of them at a time to make 4,096 byte clusters, and no file is stored with any other size than that. All right, so you typically examine a hard disk, although these days I think it's increasingly SSDs. So a hard disk looks like this. You have a magnetic platter or an array of these magnetic platters, and you have these read-write heads, which are just mechanical holders for a magnet which floats very, very close to the surface, because if you take your physics, there are no magnetic monopoles. The smallest unit of magnet is a dipole with a north and south pole, and that means the magnetic field falls as the cube of the distance. So distance is super important, so you want this thing to be very, very close, like a micron off the surface, in order to make an intense, tiny spot of magnetism to store the data densely on the disk. And so anyway, that's the platters, the spindle, and the read-write head, and this is connected. This has built-in electrical components on the hard drive which control the read-write operations, and then a way to connect to the computer over here with SCSI or one of the other connections. So a cylinder is the same track number on many platters, and you can worry about where things are stored physically on the disk. This is something people only do usually if they're trying to recover damaged hard drives. Well, the king of that is Drive Savers up in Novato, and sometimes we get to visit there. It's a very good way to make money, to recover lost data. An incredible number of people have damaged computers and they want to get data off them, and they will pay a lot to get that data back, and the experts are up there in Novato. And they have a surgery room that is a clean room where you wear the bunny suits, and they have the vacuum cleaning all the dust off your shoes, and they have a rack with extra models of every possible hard drive. So they will take the platters out of your hard drive and just put them in a different chassis with clean electronics to get the data off, and they can do all sorts of extravagant operations on hard drives to recover the lost data. All right, normally computer forensic people, of course, don't go to that limit, and if you were going to do all that, you would outsource it to some expert. Normally you just connect to machines, do something like run software on them to copy off the data you can get, and that's good enough for most examinations. But if you really need everything, or you really need to get something off a badly damaged machine, they can do it for you for a price. So virtual memory is another issue. Early computers running operating systems like MS-DOS could only run one program at a time. I used to do it in these days. You would run a word processor, you would have only text, then you would start printing the text, then you would boot up another program to print out the figures or images and print them out, and then you stick them together with tape. That's how you made things. You couldn't run two programs at the same time. Now you can, of course, open multiple windows, copy things from one window to another. So that means you have a lot of things open, and you might have only, say, 4 gigabytes of RAM, but you keep opening more and more and more programs and more tabs in your browser until you're actually using more than 4 gigabytes of RAM. Now your computer could say, no, I will not open another program because I'm full, until you close another, but it doesn't do that. It uses the page file. It takes areas of RAM that are supposed to contain program data and copies them in pages on the hard drive temporarily to free up RAM so you can just keep opening more pages. And therefore you can keep opening stuff and it works fine. But when you go back to open some of your old programs, there will be a pause while the disk spins, grind, 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 swapping the data back into RAM where it belongs. And that means this page file, pagefile.sys, has fragments of memory that used to be in RAM. fragments of programs, fragments of images, Word documents, web pages, random things are stored there. Unfortunately, they are not part of the active file system. The things you find in PageFile do not have timestamps, owners, or file names, and they can be left over from before. When I was taking one of my best forensic courses here, we had brand new computers in a lab upstairs, and they ran a forensic tool and analyzed the page file, and they found an email that I had written to my sister 4 years before in that room on the previous generation of hardware. And I said, how does this happen? He said, this is where you got to learn about the page file. Apparently, the tech that set up the new room had taken an image of one of the computers in that room, and it happened to be one I had used. And the stuff I wrote years ago was still sitting in the RAM of that machine, because Windows is mysterious. Windows will copy stuff into the page file and back into RAM strangely and at random. And it got in there and was on this machine. So when you find something in the page file, that does not remotely mean that somebody recently worked on that machine and put it there. It could be leftover from some exotic history like that. That's a problem. Also, when you find something in RAM, it doesn't necessarily mean that you know who put it there or when it was put there. Anyway, however, this is useful. It does contain information. The main thing useful about RAM is to see active things like active network connections, running processes. Those you know what's going on there. And if you look in, say, the Windows event viewer, you can find out who launched that process. All right. So you'll find settings here to control virtual memory, but normally in more modern Windows operating systems, it's recommended to just leave it at the default. Let the page file be controlled. It will have a size equal to your full physical RAM typically. All right. I mentioned before, you got to learn your binary, decimal, and hexadecimal. I'll try to do another lesson tonight so you learn how to, because this is very common. You'll see information in this hexadecimal value. So this is the hexadecimal header for various kinds of files, and we're going to do file carving. Suppose you recover fragments of a file in either the unused space on the disk, old deleted files, or someplace else like in RAM. How do you reconstruct a file when you just have a series of bytes? Well, you look for marks. Like file headers and footers appear here. So like JPEG images have this FFD8 at the start of an image and an FFD9 at the end of it. Excel has a certain pattern. PDF has this %PDF at the start of it. PK zip files have this PK in it. So there's about 100 of these known file headers and footers, and tools like Autopsy will automatically attempt to reconstruct files by just looking for the marks of headers and footers. It's not a perfect process, but it's pretty good, and you can often recover a lot of useful files from an unorganized set of clusters. You won't get file names or dates or owners, but you will get the files. So you can see images and web pages and such. So when you boot up your operating system, first, it has to start by loading the kernel into RAM. The kernel is the heart of the operating system. It is the only part of the operating system that has full privileges to all the assembly language, all the machine language commands built into the processor. It is the one that controls the hardware. If you want to control the hardware from a program you launch, like I've launched a web browser here, and I try to scroll up, I'm trying to change the visible display. But I am a user. I launched this from my desktop. I do not have the right to change anything in the hardware. So whenever you try to change something in the hardware, like what you see on the screen, you can't do it directly. Your userland process, like this browser, will make an API call to the kernel and say, please change this coherence of the screen. Only the kernel is authorized to touch the hardware. Everything else has to ask the kernel to please do it for me. And that's why when you buy any new hardware, you have to get a driver with it, and the driver has to be added to the kernel. And the driver comes to the manufacturer of your printer, keyboard, mouse, and all that. So the kernel is the heart of the operating system. However, there's normally no user data in the kernel and no user programs in the kernel. Everything you use directly, like a browser and Microsoft Word and everything, runs in userland. So in a way, for Forensic Examiner, the kernel is actually not directly very important, because that just tells you something about Mac or Apple or Microsoft, the code they wrote. The personalized information is in userland typically. Anyway, all right, when your machine boots up, it loads up the kernel, then it does bootstrapping, which will hunt for another storage device that might contain an operating system and then load the operating system. In the old days, this was done with BIOS, Basic Input-Output System. Now pretty much everybody uses UEFI, which does the same job. It's a more advanced system that can look through more devices and partitions to find an operating system and load it. It can also do a secure boot, which is an attempt to cryptographically verify everything while it's booting to make sure nothing has been altered which sounds good and currently has a lot of defects in practice. And if you listen to Paul's Security Weekly podcast, which I'm on every Wednesday, that's when Paul is an expert in UEFI security, and it is terrifying. The UEFI goes through 80 files it uses, and those things are not really verified, and there are stages that can't really be verified, and there are actually active attacks attacking the boot up process. It's not very secure at all right now, which is true, of every part of your computer. There's always a part that's well understood, and there's antivirus and firewalls and everything, and then there's another part that just haven't been looked at very much yet. And that's what the UEFI is. Anyway, the master boot record is the first sector on a hard disk called sector 0. And this is used for the boot up process. When it goes to your disk, it looks at the master boot record to say, can I boot from this disk? In order to boot, I better find certain code right here in the master boot record. And this will have the partition table, which tells you about the section of disk that have been set aside for various purposes, master boot code, a signature, and an end of sector marker. Then you boot the Windows file system. Now, in the old days, like MS-DOS and Windows 95, Microsoft used the FAT system. FAT is the original file allocation table that was very limited. All file names could only have 8 characters and a dot and 3 more characters. It had a fixed amount of space for storing it, so the disk could not get any bigger than 2 gigabytes. That's all it could store, and things like that. So FAT12 is used for floppy disks. FAT16, FAT32, and FAT64 are various versions of this. This is almost extinct. No version of Windows, modern version, is ever booted from FAT. The only thing that FAT is used for these days are these thumb drives. It's very commonly used for these thumb drives because you can read it on both Mac and PC. The problem with FAT is FAT has no security. There is no owner to files. There's no access control list. Physical access to the device gives you the right to read and write every file. It doesn't have any knowledge of what user is using it or anything. That was not present in the early computers. That wasn't until Windows NT in 1993. So now, all versions of Windows use NTFS. There are various versions of this, but they all work about the same. This is the new technology file system, and this lets you compress files. It lets you have long names. It lets you have non-English characters in the names. It has access control lists. You can say administrators have full control, but users can only read, and so on. It keeps journaling. So if you do something, like I copy a file from RAM to the disk because I'm saving a Word document, well, it saves a cluster, saves another cluster, and then blam, the machine dies because the power goes out. In Windows 98, this would create a mess. There would be these clusters on the disk, and it doesn't know what they are. And so when you reboot the machine, it would spend 10 or 15 minutes finding all the lost clusters and sweeping them into files in the root of C, file 0000, file 0001, because it didn't know what it was doing. In NTFS, they added journaling. So it records everything it does. It's, okay, I am saving this Word document. I'm saving the first cluster. I'm saving the second cluster. Now if the power goes out, it can boot up and say, well, what was I doing? Oh, I'll look in the journal. I was about to save the third cluster, so it can just pick up where it left off frequently and finish the job and not create a mess. So that's journaling. You've also got a USN, a operating secret number that has lots of things that record changes of file names and other things that you change about files. And this is what I mentioned last time. The operating system is keeping a lot of records of everything you do. Not particularly to spy on you, but just in order for it to work. But a forensic examiner knows how to gather all his records and find out what everybody has been doing on there. Alternate data streams is something I can't think of as another example of this. This is a feature Microsoft added for compatibility with Apple. Usually these guys are at each other's throats, but Apple got in media first. They had music and videos and stuff. And if you buy an album, you want to have not only music, you want to have the liner notes and the album cover art, so you have multiple streams of data tied to the same file name, and that's what alternate data streams are. Your file name is like a directory, and you can store several files inside the file in alternate streams. 10 or 15 years ago, you could actually do things like hide malware in the alternate data streams, and your antivirus engines wouldn't know to look in there, but now they do. That's someone has his note there. Yeah, viruses used alternate data streams a while ago. Now everyone's pretty much onto that, but it is one place you can hide data. All right, so the master file table is what stores the file and folder metadata, like the name of the file, the name of the owner, the access control list, the creation date, and things like that. So this is very useful. This This is called the master file table in Windows NT, and it has a database that has records for every file on the disk. It has timestamps. It can be written, of course. Every time you delete or add a file, it's changed, so a hacker can change the timestamps. However, it turns out that an MFT in Windows and NTFS stores 4 timestamps for every file, and most programs that hackers use can't change them all. So by comparing them, you can often detect if somebody's been altering the timestamps, which they often do. The prefetch folder is also very interesting. When Windows XP came out, people were very horrified when they would, Windows 2000 machines would run with like half a gig of RAM and be fine. Then Windows XP machines would come out with like 2 gigs of RAM, and you look in Task Manager and all 2 gigs are in use. And people freaked out and said, Windows XP is a hog, it's wasting all my memory, what is going on? But what it was doing is, it's not really using all that memory. What Windows XP does is it does prefetching. It notices what you've been using. I've been using Word and Internet Explorer and whatever I'm using. And whatever you've been using, next time you boot up, it preloads all those programs in RAM before you use them. Because your machine is just sitting there, and the RAM is just sitting there, so when it's not doing anything else, it's getting ready to be more responsive when you do what you usually do. So just for this convenience feature, it keeps track of what everybody does, and the prefetch folder is a dream for forensics. It has the last 128 programs that have been launched, and who launched them, and when they were launched. A nice record there of all this, so that it can preload them into memory. So this is a valuable place to go, although I'm not sure if it has who launched it. We'll do it in the projects, I've forgotten. It might be that you don't know who launched it. But anyway, it's very good. There was another thing called Superfetch in Vista, but it didn't seem to ever be used very much. However, shell bags are extremely useful. You know, if you do something like open a Finder window on a Mac. I've got a Mac here, same, where you can open a My Computer window on a PC. And so when you open a window, you can then adjust things about it. Like you can decide to view it as a list instead of icons, and you can resize it and put it down here. And the next time you boot up your machine, it will appear down there at that size in that view. So shell bags are the records of where all the windows should be. And therefore, the shell bags are a record of all the windows that anybody's been opening, when they opened them, who opened them, where they were. So as you use your programs, it's another place where everything you're doing is being recorded. And it's in the registry, which we'll talk a lot more about. Here's the path to it. It's in the HKey users part of the registry. All right. And the shim cache is a place where you have data kept from how programs for older versions of Windows run on modern versions of Windows, which is very, very common. Apple does not maintain backward compatibility at all. They only support the current version and one version back, which is a lot of why Macs are not used in companies much. They really don't support business use of Macs very well at all. They only think about home users. If you had to have an enterprise fleet of like 10,000 machines across 5 locations, you really are going to have software that somebody wrote 20 years ago on MS-DOS to do something all important at your company, like your cash register, that you're still using. You want to use old code written for old Windows, and Microsoft totally supports that. They support ridiculously old stuff because it's important for business. So shim cache is part of how it does that. It records information about how the environment of a program is adjusted because it was not really written for this version of Windows. All right, and so here's some registry notes, and here's a shim cache parser. We'll talk about these. So we'll go on to the registry, but before we do that, let's try Kahoot. We're up to the first half of this lecture, and if you weren't here last time, these Kahoots are worth extra credit. They're online quizzes, and the people that are in the top 3, they get an extra 3 points, so it adds up. You don't have to do it, but it helps keep people from falling asleep. So it's library, favorites, and that one. All right, 121. All right, so go to kahoot.it and put in that number, 420-8238. 27 people online and about 8 in the room. All right. Among other things, this increases COVID safety. My meter tells me we are not at significant risk of COVID in this room. So, anyway. All right, maybe we're ready. I'll wait till the end of the song. Aha, good thing. All right, that'll do. All right, so which one of these is 512 bytes? That's a sector, and this is in the hardware of the hard drive. You cannot read or write any unit smaller than this. You read and write in units of 512. All right, what's on the first sector of a hard disk? Boot record, which we looked into in quite a bit of detail in the malware analysis class, although not too much in this one. Anyway. All right, what file system is used by Windows? Modern versions of Windows like Windows 11. Although it's been the same since Windows 2000. NTFS, the New Technology File System, new meaning 1993. All right. What artifact records recently executed applications? That's the prefetch files. Prefetch records the most recent 128 applications that have been launched. Billy, I hope there's only one Billy. Might be. And Sid. All right, those look like reasonably real names, so my grader will probably be able to figure out who you are. All right. If you use a funny name, you can tell me your real name to make sure you get your points. But those look pretty much like real names. All right, so let's carry on then here. So the registry. In early versions of Microsoft's operating system, like MS-DOS, they used the same system Linux uses. Linux has a separate text file for every application. If you install Apache, it has a configuration file. If you install Microsoft Office, it has configuration files. There's just these little text files all over the place, a specific one for every application. For some reason, Microsoft decided they did not like that. They wanted to gather all the configuration settings into one place and call it the Windows registry. It's unfortunately not one file. For some unknown reason, it is a mess, but it is one binary object in memory. And this is where all the settings that adjust how your operating system works and how all the applications work are all stored here. So there's 5 root hives: HKey classes root, HKey current user, HKey local machine, HKey users, and HKey current config. And this is the beginning of seeing the amazingly illogical and confusing way that Microsoft thinks. Linux is designed by like mathematicians. It's all beautiful and clean and pure. It's designed the way you would design a mathematical system. Microsoft designed this thing to make money and serve the needs of business, so it's more like the way business executives would have designed it. So it's very illogical and redundant. So these things do not represent 5 files on the disk. They do not even represent 3 independent objects. HKey users lists all the information about all users, and HKey current user points to a subset of the HKey users hive that refers to the current user. So they're not even 5 independent objects. But anyway, they're loaded into memory as your machine boots up. This one contains file name extension associations like exe. In Windows, the 3 letters after the dot are really important. When you double click on a file, it launches a program based on those 3 letters, and this is where that mapping is stored. What program is tied to what 3 letters, and you probably all know this because on Windows, when you install something like a media player, it grabs the extension, and now all your other media will play with the new player and not the old one. HKey current user is the user profile of the user that has currently logged in, so this is not filled until after a user logs in. When you boot up the machine and it asks you to log in, part of the registry has been loaded into memory, but this part has not been defined yet. This thing is created during the process of boot up and login. HKey local machine has information about the current hardware, and that is also created during boot up, because when you boot up the machine, you might have changed it. You might have plugged in a new keyboard or taken it apart and added more RAM or changed the hard disk or something. It doesn't know that, so it loads the information about the current hardware during boot up here. That's the HKey local machine. And we said HKey users has a record of all the user accounts that have been created on the machine, including the ones that are not currently logged in. And HKey current config is the one that has the information about the current hardware that was found during the latest startup process. So I think, yeah, these two both are related to the current machine. Anyway, I think this one is the one particularly tied to the hardware, and this has, I think, more software settings, but we'll see. We'll learn some important forensic features in there as we go ahead. Now, another thing which you need, and we'll go through the registry in great detail later. The registry is a huge source of forensic artifacts, and you'll learn a lot of them. Then another thing to know is about what happened in the different versions of Windows. This matters. For example, Vista has automatic defragmentation. Before, the defragmentation is just reorganizing the drive. And otherwise, your drive gets all full of files that have been deleted, new files put on top to where there's not a large amount of contiguous blocks. So now if you want to save a large file like an MP3, you can't store it in contiguous blocks. You got to put a block here and a block here and a block here. And so it'll take a lot longer to read and write as the disk head has to hunt all over for it. So defragmentation just squeezes all the empty space, squeezes all the files together to make a nice block of empty space. And this is important. It doesn't matter that much on a hard drive, but it really matters on SSDs. SSDs have vigorous garbage collection in the background, where they try to clean up large blocks of empty space, and they actually zero things. So if you delete a file on an SSD, more than half the time, if you have the latest version of everything, those files are automatically erased in the background within a few seconds, and you cannot recover them with forensic software. But sometimes you can, because this garbage collection process doesn't work right. Anyway, ReadyBoost was a way to increase memory on Vista. It didn't turn out to be worth much, but the shadow copy turned out to be really important. The shadow copy started with Windows 2000 Server, and what this would do is save extra copies of important system files, so you could go back to a previous version if you fouled them up. And they expanded this to include all the files on the system now. So there is, in fact, an automatic backup process recording old versions of any file you change and keeping this up to a size like 10 or 15% of the size of the disk. And that is, of course, extremely useful for a forensic examiner. If somebody modifies a file, you can go look at the previous versions of that file and find out what they did. So that's the volume shadow copy. And HiberFile is, if you hibernate your machine, which is one of the shutdown modes when you close your lid, it will take a copy of RAM and put it in the hibernation file, so you will still have complete records of all the running processes and network connections at that machine at the moment it hibernated. So even though it's not currently powered on, you have a complete record of the RAM when it was powered on, and that can be useful. In Windows 7, added biometrics, so you can have thumbprint readers and face recognition readers supported by the operating system. And they added jump lists, which are also there on the Mac. If I go to the bottom of the Mac screen, you see these things, the same thing on Windows, and if you click on one of these, it will show you recently opened documents in that program. And this, of course, we're all used to this now. It's been in Windows 7, Windows 8, Windows 10, Windows 11, but these are called jump lists. And if you think about it, this is also recording a lot of information about what you do. It's showing the most recently used programs for recently used files for all of these programs, so that's also very useful to see what people have been doing. The Backup and Restore Center can make backups and restore points, which record the registry. BitLocker is Microsoft's encryption system, which is very powerful and hard to break, but it's very often not turned on. And for a lot of versions of Microsoft Windows, they charge a lot of money for a version that could do the encryption, so a lot of people don't use it. But you really need to use it for laptops, because if you lose your laptop on the airplane, you really better be able to prove that data was encrypted, or now you've got a data breach. So any kind of portable device should be encrypted, and corporations are smart enough to do this now. USB devices are very interesting. Every time you plug in a USB device, it makes a permanent record of this in the registry. And that's because it often has to load a driver to load that USB device, and it records that fact. And when you plug in another USB device, even if it's the same brand and model, it will make a separate record in here. So when I learned police forensics from a course I took, the guy said, this is always my first stop. I get a machine. Now you have a lawsuit or a criminal case. You get a court order to take the evidence. You go take the evidence, you find somebody's computer. Then they take it to me. The first thing I do, I'm going to spend a week examining this computer, but the first thing I do is go into the registry and list all the USB devices that have been plugged in, because you probably want to write another court order and get all of them, the hard drives, the thumb drives, because they also have evidence. If the computer's evidence, that is too. And as soon as I have a Windows machine, I can list exactly the serial numbers of every USB device that's been plugged in. So it's very handy. And you have touch screens are an option. You might be able to see what people have been touching recently. Sticky notes is like a little notepad kind of thing. And we mentioned the registry. I'll just mention here, the registry is incredibly illogical and confusing. Not only does it appear in 5 hives, which are not really 5 independent things, it's not even stored as 1 file or 5 files. It's stored as a lot of different files. And here they are: system, SAM, security, software, form the non-user dependent, and default. Those are the 5 files that store the registry that takes effect before you log in. And when you log in, there's a separate one for each user in your username folder called ntuser.dat. And you'll get very used to these as we go forward in the course. We're going to wander through these and find the important information in them and learn how to understand it. Event Viewer is Windows event logs. Microsoft, by default, the operating system keeps a lot of records of everything you do. It is incredibly chatty. If you open a folder and open a file, that will create like 200 events in the event log. It is ridiculous. But anyway, they're there. If you learn how to read this event viewer, you can totally find out what's wrong with the system, and again, what people have been doing, unless they erased it. You can't erase it. Web browsers, of course, are where most of the action is these days. Most people, all they do on their machine is open a web browser and work in that all day. So the history and the cache of images and stuff on the web browser is where they've been reading things, sending emails, chatting, and everything else. So it's very important to get this information, and the forensic tool will make it easy to see this. And then there's file grouping. You group them in folders, and you can also group the folders into libraries and such. All right. And you can even do something called federated search, where you combine other objects in libraries, but I haven't seen anybody use that. That would be a kind of exotic thing you'd probably only see in a corporation. Windows 8.1 Didn't add a whole lot more to Windows 7, which is why nobody really liked it. It was just sort of harder to use. But Windows 10 was popular again, and you had the Edge browser instead of Internet Explorer, and Cortana. Is anybody actually using Cortana? I don't even use the Apple thing that's pretty good, whatever, the voice control. Anyway, it's out there. And Windows 11, as we know, has changed the desktop, but it's largely the same as Windows 10 under the hood. So anyway, that's a quick summary of Windows versions. Let's do another Kahoot, and that's enough lecture for today. Then we'll take a break, and I'll just demonstrate some projects. So 2B. I don't know if anybody actually uses smart speakers with that voice mode very much. I only know one person with like an Amazon smart speaker at home that uses it, but she works for Amazon. So from what I've heard, all this voice control stuff kind of came and went. Does anybody actually use it and like it? Yeah, that's good. It really was, they had pushed it real hard like 3 years ago, and then I think pretty much everybody found out it wasn't really that great. Yeah. Alexas, yeah.
Yeah, we don't even use them.
That's right. I think that's what.
They have paired them with the smart light bulbs.
Yeah.
Turn on lights and
Yeah, what's the point of a smart light bulb either?
just,
I saw a survey recently that said that people found like half the smart devices, they never even hook them to the internet. Because all you wanted was a toaster or an oven or something. Why would you bother? Whatever those network features are, most users really don't care.
yeah, we got those light bulbs for Christmas.
Yeah. Yeah.
Exchange between the family because I will try to support for this and we thought I don't like them for some reason.
Well, sure. Well, it was the thing, right? Get everybody to love it, but, too smart by half, too clever by half. That's what the British say. When you do something that sounds good, but you can't really go, oh, what's the deal here? I think something weird on my Twitch. Okay. Someone has a question about Kahoot. Where do the questions come from? I make them up. So sometimes they're wrong. If I attend the in-person class, does the college provide computers? You can bring your own computer or you can use computers. There are computers in the classroom. Either way is fine. Does Windows still keep thumb views that aren't deleted? Yes, it keeps thumbnail images. Yeah. Even I think if you delete images, it still keeps the thumbnails, so you can recover them with forensic tools. That's what I mean. If you are doing something on a computer and you want to lie about it, you got a big problem. There's a lot of evidence on that computer. And there are programs you can get like Evidence Eliminator that try to get rid of it, but I doubt they're very effective. That would be a good project for a student, would be to like run Evidence Eliminator and then see how much evidence you can still get afterwards. I haven't tested it. It would be a good thing to test. You have these forensic tools, maybe I'll put it in the project. Then you can run an Evidence Eliminator and run it again and see what it really got rid of. I guess it will get rid of your browser history and cookies, but I really doubt it's going to get rid of the registry settings and everything. And just like in stopping malware and hackers, it's a defense, and so it will stop attackers that are not strong enough to punch through that defense. But that's all you ever get. You make a fence this high, it'll stop some attackers, but not others. So, Evidence Eliminator might fool, like, your kids who don't know much about computers. But maybe not. All right. Guess we got enough people. All right, so what registry Hive contains the current desktop settings? All right, that's HKey current user. It has to be because it can't draw the current desktop until after you log in. And it knows who you are and what your background picture is and all that. So HKey local machine has information, and current config is like the software configuration before you log in. This is the one that knows who you are, and you have to know who you are in order to draw the desktop. The desktop does not appear until after you log in. All right, what artifact contains copies of all or part of a volume? All right, that's volume shadow copies called VSS, and we'll play with that. That's quite useful. One thing that's bad about it is if you delete a file, the shadow copy's gone too, so that's annoying. Anyway, which feature will encrypt a hard drive? All right, that's BitLocker, is Microsoft's solution. In Apple, it's File Vault. All right, what registry hive contains file name extension associations? All right, HKey classes root. That contains the connection between those three-letter file name extensions and programs. So, that's Space Hex. Well, I have to tell me who they are if they want their points. And Sid, okay. I think it's the same Sid that won last time. And Billy, probably the same Billy that won last time. All right. So let's take a 10-minute break. We'll pick up 7:10, about 13 minutes. They stretch your legs, and then I'll just demonstrate a couple projects. And then by 7:30, I'll just be able to answer any questions from anybody. I'm going to lock the screen and walk away myself. I'll be back. Space Hex is Alejandro, good. I'll make a note of that. Good. I don't know if I can put autopsy on this ARM-based machine. I'm going to see. Oh, recording is still going.